Hello, this movie is for Learning Target 10 and 11, equations of lines and equations of parallel perpendicular lines on a coordinate plane. So the first thing that we want to notice is that reminding ourselves that in algebra we learned a negative slope is for a decreasing line. A slope of 0 is a horizontal line, positive slope is increasing, and a vertical line is undefined. One way to remember that is what we call hoi vux. It means horizontal, has a slope of 0, and y equals a number is the equation for the line. Vux is a vertical line with an undefined slope, and x equals a number is the equation of the line. Slope is your change in y over change in x. It's your rise over run, and it's always the reduced fraction. So make sure you're always reducing. For example, if I went up 2 to the right 2, that's 2 over 2. Now that reduces to 1. So make sure you're reducing all of your slopes. Find the slope of the line that goes through these 2 points. You want to do change in y over change in x. So I like to label my x1, y1, x2, y2, and my change in y's are my y2 minus y1. But as long as you pick a direction and you're consistent, it's fine. So negative 4 minus 8 and negative 12 over 10 minus negative 2, which of course is 10 plus 2, which is 12. So this gives me a slope of negative 1. To find the slope of each line, slope of A, I go up 1, 2, 3 to the right 2. So up 3 to the right 2 is my vertical change over my horizontal change, my rise over run. Slope of B, B is a horizontal line. If I remember hoi vux, horizontal is y equals a number with a slope of 0. So that has a slope of 0. C is a decreasing line, and I go down 1, 2, 3, 4, 1, 2, 3, 4. Down 4 to the right 4, which is negative 4 over 4, which is negative 1. Again, always reduce your slope. So that's a little reminder of slope. Equations of lines. So you remember slope-intercept form, y equals mx plus b. You've dealt with that in Algebra 1. M is your slope, b is your y-intercept. There's something called point-slope form, and if you're in honors, you're going to want to really listen to this because point-slope form will set you up very nicely for honors pre-calc when you take that. Point-slope form stems from a point, x1, y1, and a slope of m. You can see that x1 is plugged in here, y1 is plugged in here. So we have this equation, y minus y1, which is the y-coordinate of the point, equals m, the slope, times x minus x1, x1 being the x-coordinate of the point. So point-slope form is really good when you're given a point and your slope and you want to go to an equation of a line. Standard form is ax plus by equals c. A and b cannot both be 0, a, b, c are integers, and a is not negative. So having that practice of going from slope-intercept form to standard form is really important. For example, slope-intercept form can look like y equals negative 2/3 x plus 5. To change it to standard form, the first thing I would do is get rid of my fraction by multiplying both sides by 3. Now the 3 gets distributed in because you distribute over addition. So this gives me negative 2x plus 15. Then if I add 2x to both sides, I get 2x plus 3y equals 15. Here's my A, here's my B, here's my C. A and B are not both 0? Check. A, B, C are integers. Yes, check. And that's why I multiplied by 3 to get rid of the fraction. And A is not negative. Check. So this is my standard form for the exact same line that I started with in slope-intercept form. So being able to fluctuate between the two will be very important. What is an equation of a line with a slope of 3 and a y-intercept of -5? So a slope of 3, y-intercept of -5, I'll probably just go to y equals mx plus b. Plug in m, plug in b, and so I get y equals 3x minus 5. That's my slope-intercept form. What is an equation of a line that goes through this point with a slope of 2? Well, notice this point does not tell me anything about the y-intercept. So I'm going to label that as my xy. I'm going to go to y equals mx plus b. I'm going to plug in this value, my slope for m. So that is going to become 2. I'm going to plug this value in for x and this value in for y. 5 equals 2 times -1. And then I'm going to leave b as b so that I can solve for it. So I get 5 equals -2 plus b, and I add 2. 7 equals b. So now I know my y-intercept is 7. So I get y equals 2x plus 7. Now, if you're trying out point-slope form, this would be for an honors class, point-slope form would look like this. Y minus y1 equals m times x minus x1. This is your y1 and x1. So I would get y minus 5 equals 2 times x minus a -1, which is plus 1. And then I could just distribute the 2 in, and then add 5. And I still get y equals 2x plus 7. So you could start with point-slope form or use slope-intercept form. Write an equation for a line that goes through these 2 points. Well, the first thing that I need is my slope. So I'm going to do my change in y over change in x. And I'm going to choose a direction. So I'm going to go this way, which means I do -5 minus 3 over 11 minus a -5. So this gives me -8 over 16, which is -1/2. So that's my first step. Then I get to choose either of these points to use. And it really does not matter which one I choose. I'm going to go with the 5, -5, 3. I'm going to make this my x, this my y. I know that my slope is -1/2, and I'm going to plug that into y equals mx plus b. So I get 3 equals -1/2 times -5 plus b. So this gives me 5 over 2 plus b. I'm going to multiply, actually I'm going to subtract 5 halves. So I get 3 minus 5 halves, which gives me 1/2. Feel free to use a calculator if you want. So I know my y-intercept is 1/2. So that is y equals -1/2 x plus 1/2. And that's how you get an equation. Now this is in slope-intercept form. I could get it in standard. So to get it in standard, I would multiply both sides by 2. Why 2? Because that's my denominator. So I get 2y equals, now that gets distributed into both, which gives me -x plus 1. So then I would add x to both sides. X plus 2y equals 1. And that's my equation in standard form. ax plus by equals c. A is 1, b is 2, c is 1. How can you determine if two lines on a graph are parallel? So parallel lines are two non-vertical lines that are parallel. Their slopes are going to be equal. That's how we know if two lines graphed are parallel. So if this has a slope of 1, 2, 3, 1, 2. So the slope of this is down 3 to the right 2, -3 halves. I could choose any point on here and go down 3, to the right 2, down 3, to the right 2, down 3, to the right 2, and this line is going to be parallel to the original line because they have the same slope. That's how you know if two lines graphed are parallel. Are these two lines parallel? Well, let's find the slopes of each, L1 and L2. L1 is going to be change in y over change in x. So for L1, I'm going to use these 2 points. And so I'm going to do -4 minus 5 over 2 minus -1, which gives me -9 over 3, which is -3. For L2, I'm going to use these 2 points because that's my L2. And I'm going to do -4 minus 3. I'm going to go that direction like I did with that one. And -1 minus a -3. So this gives me -7 over 2. Looking at these two lines, they kind of look parallel, but the slopes are not the same. So no, since the slopes are not the same. Write an equation that is parallel to this line, meaning it will have the same slope. So my slope is going to be -3, and it contains this point, -1,8. So I'm going to use y equals mx plus b, plug in this for 8 for y. I'm going to plug in my same slope, so the slope is -3, plug that in for m. My x is -1, and I'm going to solve this equation for b. So this gives me 3 plus b, so I subtract 3, and I get 5 equals b. So that's my y-intercept. I go back to my original slope, it's parallel, so it's -3 x plus 5, and that will be my equation in slope-intercept form for a line parallel that goes through that point. I'm going to leave that last one up to you, and that's the end for this movie. This is Learning Target 1011 Part 1, Parallel.